Hi, my name is Matthew Ascott. I'm a hydrogeologist at BGS. In this presentation, I'm going to give a quick overview of the source modelling we've been doing for groundwater sources in the historic Droughts project and for endows. I'm particularly going to talk about a groundwater model that BGS have been developing, which has been built to assess the relative influence of climate change and permeability on estimates of borehole yields during drought periods. So one of the main challenges faced by water companies when estimating the impact of climate change on borehole yields is that understanding how groundwater levels behave below the lowest observed groundwater level in pumping boreholes can be particularly challenging. In many aquifer systems, permeability decreases with depth, which can cause greater drawdowns in pumping boreholes. The conventional method that we use for estimating the impact of climate change on drought borehole yields is a simple curve shifting approach that you can see here on the left-hand side, where you've got a drought bounding curve based on the shape of the step test curve and some operational data, which is vertically shifted downwards. Now that simple shifting represents a best case scenario where permeability doesn't decrease further with depth. However, we know that there are substantial decreases in permeability with depth in a number of aquifers in the UK and beyond. The example on the right there is the classic cocktail glass reduction in permeability with depth that's applied in the chalk. So the question we set out to answer in this research was really to understand, when looking at borehole yields, what's more important? Is it the impact of climate change associated with curve shifting, or is it the impact of changes in permeability with depth? And how do those two relate to each other, and which is more important? So to do that, we developed a simple conceptual groundwater model for an idealized site focused in the Kennet catchment in the chalk in southeast of England. Here's just a quick schematic of the model that we've developed. Basically, it's a radial groundwater flow model, and we stress that model using a number of different recharge scenarios, which are perturbed by the climate change scenarios from UK CP09. We apply a number of different permeability profiles, looking at the changes in permeability with depth, and we apply a number of different abstraction rates. And then by applying all these combination of abstraction rates, recharge scenarios, and permeability profiles, we undertake a number of steady-state groundwater model runs from 1970 to 2015. So having applied all these groundwater model runs, we then assessed the relative impact of recharge and changes in climate and permeability through the permeability profiles on both pumping water levels and estimates of yield. And what we find is that changes in climate are less significant than changes in permeability on groundwater levels, and both factors are very important and equally significant in estimates of borehole yields. So it's something which should be considered in future yield assessments if possible. Now, the next step for this research is to apply this conceptual idealized model to a real-world site. And if you're interested in collaborating with BGS on this, or you'd just like to find out more, please do get in touch with us via email or at the Drought workshop on the 29th of October. At the workshop, we'll be discussing more about this modelling approach and some of the outputs that it's producing, as well as our reconstructed groundwater levels, which we've been developing in the historic Droughts project, which is for 54 sites back to 1891. So it's a large data set which can be drawn. Thank you very much.